we have air, we call this the air truss because we need around, the reason why we make a budget because we need at least 25-meter air truss.
I know, I understand, sir. Hindi ko sinasabi na
No. Let me first.
Naiintindihan ko na your design is based on a high velocity, air velocity to throw from the edge to the middle, di ba? And mechanical engineer din po ako, so naiintindihan ko yun. So,
let me first handle the question. If I'm using that, what we call that data, because as I understand, acoustic consultant is different from the mechanical, no? We can design, but in terms of the acoustic or something, there is what we call that a familiarity or an expertise. Now, the moment if we apply this on what we call that on the some high speed velocity, no, based on the ARI standard right now, do the figure of around, for example, NC30 and NC35. Applicable on the high volume we have. And if we make that, what would be the guarantee standard that, for example, if we have, for example, an air truss of around 25-meter air truss, doing that kind of what we call that application on NC, meet the standard we have in terms of the...
I understand, sir. There are two things that you have to meet. You have to meet the cooling capacity.
Yeah.
But we're saying now, it's best to meet that cooling capacity while doing it quietly. Now, ang issue ngayon is, tama your design is correct. It cools the arena. But it did not take into consideration the noise. If we had designed it in the beginning with noise in consideration, we probably wouldn't have used high velocity jet nozzles. We would have probably used big ducts and use overhead grills. No? Pero you already did the design, so I understand now with your design, it's going to be almost impossible to meet that. And if we force it to meet that, we will not meet your cooling capacity. I understand that perfectly. Agreed?
Yeah.
So it is our goal to try to quiet down your aircon as much as possible. I'm not saying we're going to I don't think we can achieve that. I don't think. Mechanical engineer din po ako. No? So, I know I can compute the duct lengths required and the duct liners required and everything. Alam ko, imposible na yan. I know that's impossible.
Maybe on some areas siguro, no?
Yes,
like for example, you have the around 3 to 4 meters or 5 meters, which we are using a circular diffuser.
There, yes,
because, so maybe that's good, no? Because honestly, I'm thinking because for this project, they have a acoustic consultant from the Europe, and that's the reason why from time to time we are working. But it's good right now since kayo yung nandito. It's best and
was there a target decibel level that the designer?
Yeah, honestly, for example, the AHU we have, no, because this type of dome is the biggest. And when I designed this using Daikin AHU, from 150, I make it into 200 tons because from 60,000 we lift up to almost 75. And there's no air handling unit now can produce the 200 tons, no? That's the reason why I'm designing this.
What you did is a good step. Kasi for us, the bigger the unit, it will be working less hard, so it will be less noisy. So we always overspec the aircon, so it will be running on low, not on high.
That's the reason.
So you did well by overspecking the aircon.
The problem right now is how to control the phase velocity.
Yes.
Because it's a two variable. You can have a better comfort cooling, but sometimes the noise will be sacrificed, and that's the reason why I understand for this. So maybe on some of the areas, if I will ask the kingdom, because as consultant, I need first to ask them to what we call that. We can apply this on some areas which is have 3 to 4 or 4 to 5 meters for the circular diffuser, no? But on some of the cases, that's the reason why I'm trying to vote, because again, the design of this is not similar to other what we call that.
Like this, sir. Let us evaluate what you have. there's a lot of things I have to look at. Understood that if you have a jet nozzle design, there's no way you can have low velocity. Okay. Pero I'll have to compute now where the jets are and how far they are from the people to know exactly how loud it will be. And then I will also need to know if we are going to employ all the acoustic materials that Sir Joe is recommending for the ceiling,
Correct.
because all of those materials in the ceiling will also help quiet down that aircon. So yeah, like everybody's saying, it all works together. Everything affects each other, and that's why I'm here. I'm trying to orchestrate each piece to make it all work together in one. You know? The aircon, acoustics, the sound system. Yun yung trabaho ko. That's my work, to make sure that each piece fits together properly. I have to check that their speakers are pointing in the right direction, and that the surfaces are treated where their speakers are pointing, and that the aircon is not noisy where the people are sitting. So, like, if the big ducts that going up from the air handling units, if there's someone seated beside that duct, maririnig niya yung ugong ng duct, di ba? So, as of now, I'm already going to recommend na tambulan natin. Let's cover those ducts today.
Actually, sir, excuse me, no? The plant room we have, no? We have the 8 ramp, no? It's composed of around five units of 200 TR, that's 1,000 TR. Because the dome right now is 10,600 TR, no?
Yes.
The biggest sofa right now, arena is 7,600. But this is designed by 0.52, and we try to use what we call the CO2 and an oxygen sensor to modify whatever. But in terms of what we call that sounds, we will give you the decibel based on the high frequency, maybe around 103 or something, so that we can go back on what other things we need to what we call that. So just let us know if what other things.
Like you're saying, sir, at 103 dB, we will already have to treat the air handling room mismo.
Correct, sir.
We will have to line the walls in the ceiling just to contain that sound.
Correct.
So lahat of all of this we can take a look at
Correct.
and make recommendations.
And lastly, sir, I understand that there is sound attenuator. No? We discussed as much as possible. I try to what we call that a limit, because right now we are trying to attain at least 11 to 12 meters per second phase velocity. And in order to accomplish that, for 200 tons, even though the US manufacturer said Joseph cannot make, and that's the reason why right now, if I am using what we call a sound attenuator, at the end of the farthest distance, the pressure drop I have is very big.
Yes, understand.
We try to use right now we call this internal duct liner, which is a materials coming from others. So
Standard po naman sa amin yung interior duct liner.
yeah.
But it's usually 3 meters after the air handler and
Correct,
3
sir.
meters before the discharge.
Correct.
So that's only good for about 10 dB maximum. No?
That's the question I have, sir. If
Para
ever
we
I
need
put
more.
in around 3 to 4 meters, what, based on your experience?
Studies show after 3 meters long, there's no effect. That's why it's best to put it in the start and in the end. In the middle doesn't matter.
More or less, sir, we can drop from 100 decibel to around
80, 90.
80,
90.
You will give you some info on that.
Okay, sir.
Engineer, we also need to know the height from the diffuser to the.
Yeah. We will
Ganito lang sir, gawa na lang kayo ng ano. Yes,
This
please.
requirements.
Diba?
Perfect. Yes, sir.
Sabihin sa amin, para doon na lang namin
Yes.
ano.
Right.
Like yung glass natin. So may design na yung glass natin, which is 8 by 1.52 by 8. Yan yung double, siya eh.
Laminated. So 16 mm laminated.
double glaze.
8 by
8 PDB,
1.52.
8. So 16 with the laminate in between. So 16 mm total. Makapal na. That's enough. That's more than enough. Yeah, we look at that. I think that's.
So, hingi na lang kami ng
Yes.
listing nyo para perfect yung design nyo.
Opo.
You can answer, you can formalize, because as consultant, whatever they ask, cannot give any transmittal or something.